The MoneroTopia guest segment is sponsored by Cake Wallet. Store, send, receive, and exchange your Monero and Bitcoin safely on iOS and Android too. Cake Wallet is open source, and you always control your own keys.
All right. So recently, I guess it was around 2 weeks ago, it was a couple weeks ago now, we released version 5.4 for Cake Wallet, which introduces this really useful feature which we call Pay Everything or Pay Anything. And there's various wallets that have had features similar to this with different names. But effectively what this does is it makes it really easy for you to pay a different coin from the wallet you're already in. So we're trying to make Cake Wallet a lot more dynamic. And so you will be able to scan a QR code that could be any cryptocurrency. And it doesn't matter what wallet you're in. Cake Wallet will recognize that and say, oh, this is a Bitcoin address and you're in a Monero wallet. Would you like to switch to an existing wallet, or do you want to swap from this wallet? So this is what it will basically look like. So you'll basically end up scanning a QR code. And as you can see here, Bitcoin address detected in a Monero wallet. And you get the prompt that you could swap. And if that QR code has information filled in, like it's got, let's say, a dollar amount filled in. So it's a QR code that you scan that has an exact amount of Bitcoin or an exact USD amount, it will get that information as well. And it'll generate a swap that has a fixed value. So the rate does not change. It's not dynamic. So this is really useful if you're someone who wants to use Monero as much for paying. So let's say you want to pay for this VPS service, or you want to pay for this food or something online, and they take something common like Bitcoin or Litecoin, but they don't take Monero. What a lot of people do, they will go through the process. They'll swap Litecoin, or they'll swap Monero to Litecoin directly to pay for that invoice. Well, this is just a nicer and quicker way to do that. It's a lot more automatic. It's a lot smoother. And here is what it looks like with switching the wallet instead. You just tap switch wallet on the bottom, and it's going to show you what wallets you want. And now you've switched to a Bitcoin wallet. So nothing groundbreaking. However, it does make the process of being able to just pay anything way easier. And of course, what's really useful about this as well is that if someone gives you a QR code and you want to scan that QR code and it's for a cryptocurrency that happens to not be in Cake Wallet, there's a good chance that we still support swapping to that currency as well. So that is a feature that came out a couple weeks ago that we are improving on. And then also, this one's pretty big. We now have we have native Tor on iOS. So this is a feature that we had for a little while for Android, but we now have it on iOS as well. So if you're an iPhone user, you can enable Tor directly inside Cake Wallet for accessing nodes over Onion. Now, once again, similar to Android, this is not something that's going to necessarily cover all connections in Cake Wallet. If you want something like that, you need to have a dedicated VPN solution on your phone. However, this is very useful if you host an Onion node at home and you want a quick, easy way to access it without having to install Orbot or setting up VPN profiles. You can do that inside Cake Wallet now. You see, you get this green little onion when it's synchronized and connected. So that's great. So that is now a feature parity between iOS and Android for the most part, and that will continue to be improved upon with performance and then covering other connections in the app in the future as well. So that is 5.4. And I don't think there's been any other major advancement since then. We do have a minor update that came out recently, fixing some bugs with Pay Everything. And we will have a much bigger update coming out next week that will finally have the long-awaited black themes with the ability to choose a few colors. And that will be very, very awesome. I can't wait to show you guys that update because we worked really hard on making them good. And then we have a lot of other things in the pipeline as well. I wish I could talk about them. I really can't yet. Some major updates to Cake Wallet, how you will use it, and the smoothness of interacting between your wallets. So hopefully within the next few weeks, I'll start to be able to show you guys some of that stuff. But there'll be some very, very big, some huge updates coming soon for the entire wallet, and even the Monero experience will be better as well. So
very nice. Well, I'm actually set up here, so if
Yeah. Let's go ahead and let's see. You were able
Give
to.
me 1 second. I'll share my. Do I have 2 windows? Oh man, I was hoping to put. Yeah, there we go. The entire screen. All right, it should be sharing now. All right, so you can go here to GitHub. So just BawdyAnarchist, github.com, BawdyAnarchist, Monero Simulator, and you're just gonna grab the You'll need to install. I already have JavaScript, Node.js installed. So I know everyone hates Node, but honestly, it's better than Python, especially for stuff like this.
I saw your rants about Python.
It was just like
and
one
the
rant.
with the indentation.
Yeah, I mean, it's a small thing, right? Like it's not like it's fine. It's fine. It's just that it was actually an insight that had. It's like, wait a second, that's actually a confounding of separation of concerns there. The notion that you would use indentation as your means of code block encapsulation, as confounding those two things, you lose a level of versatility of both of those things because they're separate purposes. One is for presentation readability, for organizational purposes. The other one is actually a fundamental foundational bedrock concept of code, which is a code block. And so when you confound those things, you kind of lose the versatility of both.
It is kind of a weird requirement, but I guess from the sense of a lot of new people learn Python, it kind of forces them to make their code presentable and laid out correctly. It kind of forces them to do that. Like, it's still not ideal. It's silly, but I can understand in the sense of it being beneficial to people who are new to programming.
There's that kind of like, it's a use the good indentation practices as a forcible means, but it also kind of obfuscates the notion of code blocks. Like, it's like you don't really understand. Like, even myself, it was some years into coding until I really started understanding that, like, the foundational aspect of a code block and what it truly is. And you know why? It's because I did shell coding. Most of my coding was in shell, so I would do all these loops, and you don't necessarily have like clear code block. I mean, sometimes you do, like functions, obviously, but your loops don't always necessarily have like the clearest code block boundaries. But anyways, no, JavaScript is better for this use case because it has this thing called a just-in-time compiler. It's a scripting language, but it compiles in advance, right? So it looks at the hot paths and it says, oh, I've run this hot path, twice already, and it looks like I'm going to run it again. Let me store everything. Let me compile that. Let me put all the consonants that can be compiled, and then it runs. A well-written program can run almost as fast as C code if you're doing a lot of loops, which a simulator like this inherently does a lot of loops. So it's actually the better choice, believe it or not, unless you want to go with Go or C, right? But who wants to write a simulator like this in C? That's going to be too hard for people to follow. Anyways, all right, moving on. So yeah, you're here at my repo. You just copy this to the clipboard, and then you just do a git clone. It's going to clone, and then you're going to change directory into the simulator. And then here's what it looks like. I know it might seem a little bit confusing. The source code, for those of you that don't know, right? This is the source code. These are your configurations. This is the magic of how it works so well. All of your data gets dumped in here. If you want to read about what's going on, go into docs, and then you might have some logs if you want. What you need to do is look inside of this package.json because that tells you the modules you need to install. So we're just going to show what's at the end here. So dependencies, right? So after you've installed Node, right, Node.js, you're going to do npm, which is like their package manager, and you're just going to install all of the stuff here, right? .environment. By the way, this is like a new environment, right? I haven't actually done this here on this environment, so you'll get to see the proof that it works. Oh, I just did npm. We have to do npm install, obviously. All right. So then what you can just do from here, so here's what's in the data directory, nothing. And then you can just do npm start. In fact, this is the first command that you do want to run because it copies your configurations into the locations they need to go. So you're going to run npm start, and then we can go into the data directory here. And look, we have results now. How amazing, right? So if you wanted to see, let's just go to, these are all the blocks that were produced, right? So this looks a little bit dirty because I don't have the widescreen going on, right? Because I'm showing you both sides, but effectively, these are all of your blocks, right? And so we have 31 blocks, and I'll show you why it was 31 blocks because if you go into your environment, so .env is your environment. This is where you set up This is where you set up your simulation. So how many hours of how many simulated hours do you want to run? We only ran 1 hour, 30 blocks, right? Or 31 blocks in this case. Right. We only ran this for 1 round, and there's 1 worker. So you can parallelize this stuff. So anyways, these are all your settings. You'll notice here we have like Monero's exact difficulty algorithm settings. These are actually just lifted straight off of difficulty.cpp in the Monero code base. And then you can set a reproducible seed. So all of these rounds, they're not totally random. You can reproduce the randomness by changing this seed. So you can verify each other's results. Ping, this is in milliseconds. So if you want to simulate like a network that's heavily degraded, you can set this to like 2 seconds. And I have some magic on the back end that simulates spiky problems. So like, we won't get too much into that, but if you want to read the documentation if you're interested in this. But the point is, you can change the ping, you can change the network parameters. Don't change the CV. And then you can say, hey, how far NTP standard deviation is how far off is the average NTP clock of each pool. So this is a pool-based system. So actually, let's go into dot environment, and I'll show you something really cool. Let's run a sim depth of 1,000, right? So 1,000 hours. So that would be what, I don't know, like a month, about a month of time. Oh wait, it says right here, 720 hours is a month. So it's about a month and a half. And let's run 10 rounds of this thing, right? We'll do this with 20 workers because I have a decent CPU. Actually, let's just do it with 30 workers because, oh no, wait, we're only running 10 rounds. Actually, let's run 30 rounds. Fuck it, why not? All right, so what we're going to do is come here to npm start again and grab that environment, and you'll notice, hey, here it's running all of our rounds. It's going to take just a moment to complete. Probably should take about 7 seconds for each 7 seconds for each round. It's taking a little bit longer than it usually does. Maybe something's, oh no, here it goes. Maybe it's just because I loaded up. All right, yeah, so you can see that was, maybe that was about 10 seconds of time to run 30 rounds, and then we can go into our data directory again, and you can see here's our second run that we did, right, 002. Now, one of the cool things that I have is this summary right here. So let's just go ahead and look at that. So what's happening here is we're summarizing a bunch of different things. So this is all the rounds that were run, right? We ran 30 rounds. This is the orphan rate for every single round on the basis of what we have programmed, and I'll show you how you change the pools. You can change the hash rate, and you can change the strategies that they're using. Anyways, so in red you see this is the orphan rate. And then this is just the standard deviation of the orphan rate, because every single pool sees a slightly different view of the network. And so I average over all the pools. And so that's what this standard deviation is here. If it's high, it means that there's actually probably a network partition. It's just it's a double check to say, okay, this is all zeros. That means that every pool is seeing the same network. They're all, they all saw basically the same thing. So you can see what was the maximum reorg length. That was just 1.0. And then the reorg P99 is like, the 99% of all of the reorgs fell below this number. So 99% of all reorgs that were seen on the network fell below one reorg. Let's see. And then we have the selfish profit. You'll have to read the documentation for exactly how that is, but it's effectively the percent as a fraction of profit that they made in comparison to the rest of the network. So let's go to the config directory. So this is where the actual pluggable magic happens. So this is your default environment. Don't change this file. Anything that says sample or default or example, don't change those files. These are the actual files that the simulation is using to run, right? Like pools.json. So let's go in here to pools.json, and you can see this is where you define what strategy each pool is going to use. You can see we have 8 pools, and this is the hash power that each one of them has. So I actually just lifted this off of the Monero, some snapshot in time of the Monero network, right? Of who has what hash power. So this is something close to the distribution of the pool's hash power, right? So that's 31%, 22%, 17. Obviously, this has to add up to 1. Let's do something interesting now. So you saw on our data when we ran that simulation, you saw that there was only there was a depth of 1 on the reorg, and that there was no profit for the hash power. Let's do something interesting and change this. Actually, let me show you where the keys is. I can't remember. I think it's SL0. Yeah, SL0. All right. So what we're doing here is we're saying we want pool 0 at 31% of the hash power to run a different strategy. right? So the pool is going to run a different strategy, and S is what I use for selfish, right? So there's a whole bunch of different selfish strategies you can use. It's actually fairly elegant the way that I coded this up. Anyone that really loves code will come see this maybe and be in awe of my neat coding, my leet coding prowess. So anyways, let's get out of here. We just changed that to SL0. So what does that mean though, right? What the fuck does SL0 mean? That's why we have a strategy manifest. This tells you what each of the strategies are. So HB0 is our honest baseline. This is what we're currently running. You'll notice here's the config policy. It is true, right? Say, is it an honest miner? Yes, it is. So in that case, these are selfish mining parameters, kthresh and retort policy. These are only relevant for selfish miners. So we just set them to null. And what you do is you say, here is the module that I want you to use for this strategy. So this is where the plugin thing happens. That's really cool. You'll notice this is a file location, plugins unified pool agent. So let's just get out of here really quick and show you what I mean by that. So we're going to go into the source directory. And then, so here's where all the actual source code lives, right? So you pull in your config, you do some orchestration for the multiple workers. Here's the actual like engine that the sim is running. And then we have these plugins here. The plugins is where you have this, like, the pool is its own agent, right? It has to make all of its own decisions, and it doesn't care what the physics of the network looks like. It's just making its own decisions. So we have the unified pool agent here, right? And this is where we won't get into the code, but, just showing you quickly that, this is where all the decision is made. And what's cool is that this agent represents both the honest case and the selfish case. The fact is that the selfish has to do all of the things that the honest does, plus layer in their own selfish strategies on top. So anyways, what you can do here is you can write your own agent, right? You could say, hey, pool agent number 2, right? Agent Zeta, or name it something cool, doesn't matter. And you can also write your own countermeasures, right? You can say, hey, rich uncles and depth penalty, right? You could write that into here. I've actually integrated some of that stuff already. I haven't written the actual scoring for depth penalty and for uncles countermeasures, but I will get to that once the sim is like tip top. Okay, so anyways, that's showing you, here's the file, right? Plugins, unified pool agent. So we're going to go backwards and then go back here into the config. All right, so here's our strategy manifest. Hopefully that makes more sense now. Here's our pool agent that I just showed you, right? So you can write your own, you can plug it in, and then you just add a new module here. You just add a new object here to the JSON, or JSON. I don't know what people call it. Anyway, so here's SL0, right? So this is a version called lead stubborn mining, where it's stubborn because traditional selfish mining tries to gain a lead, like maybe they get +4 blocks to the honest chain. And then if the chain is about to catch up, then they'll publish to safely claim their lead. But stubborn means that, hey, we're actually willing, so kthresh here, we're actually willing to tolerate the chain catching up to us because we're going to gamble that we're going to grab a lead again, right? The chain is 0 with us. It's actually called 0 prime in the literature. And you're saying, hey, we're going to tolerate the chain catching up to us. We're going to be stubborn and not publish our alternative chain. And so you can do things like change the retort policy here. Retort policy implies what are you going to do when the chain publishes a single honest block? Are you going to try and stay ahead of them? So if you're going to always stay ahead of them and clobber their chain and always own the chain, you're going to have a retort policy of 2. A retort policy of 1 just means if the chain publishes an honest block, we're going to create contention for the chain head by publishing one of our reserves. And then a retort policy of 0 is pure silence. And that's what Cubic has been doing to reorg the chain. They don't publish anything until they're ready to reorg the chain. And so stubborn silent is actually the one that causes the most disruption to the chain. They are, again, false. They're not an honest miner. They're willing to tolerate. They're willing to tolerate the chain catching up in hopes that they will get ahead again. And then their retort policy is 0. It's silence. So that's SS0. What we can actually do here, let's exit there, and then let's go into the pools JSON again. Right now we have SL0. Let's actually do SS0, right? Let's make them a silent stubborn miner at 31% of the hash power. So that's our setup, right? Hopefully all of that has made sense. And then what are we going to do? Let's remove what's in the current data directory. Right. So we just got rid of all that data. And then we're going to run npm start. Oops. npm start. We're going to run npm start again. Oh, actually, you know, one more thing. Let's go into the environment. Do we need 1,000? We probably don't need 1,000. Why should we wait? And we don't really need all of these extra rounds either. So we can just delete that. And yeah, I guess 100 hours is fine. It's about 4 days. All right, so we're going to run npm start again. And very quickly, you know, we ran 4 days like it was nothing. And here's what we're going to do. We're going to go into our data and we're going to analyze the summary. That's all we're going to look at is the summary. All right, so in 4 days, what is the maximum reorg that this strategy was able to do? 30 blocks. They reorganized 30 blocks. If you give them 4 days, pure 100% mining on this strategy, that's 30 blocks they were able to reorg. Notice over here, though, that selfish profit, they had to pay 14% of the profit that they could have made just by being honest, right? So they're down 14% to do this reorg. Other selfish strategies do give them slightly more profit. If you use if you don't play the pure silent strategy, you can gain more profit, especially if the network has a little bit of like if your ping is a little bit worse, right? Under slightly degraded network conditions, it becomes more profitable. Their profit starts at around 33%. So if they're using one of the non-silent methods, their profit starts at around 33%, and it's not much. It's like, you know, that's the 0 point. So if they're mining with 35%, 40% of the network, they're still only gaining like 5% more profit than they would otherwise. So the magic, so I told you guys about sweeps. Let's go into the environment. Let's suppose that we wanted to see how a strategy performed under various pings. When I say sweep, I mean that I want to run a single round that does a ping of 70, another round at a ping of 100, another round at a ping of 500 milliseconds, another round at a ping of 1,000 milliseconds, right? So that's 4 different levels, 4 different rounds I want to run, and I all want to have them run under the seed of 1. I want them to all be exactly comparable. So when I say I want to implement sweeps, what I mean is that I want to run rounds. I want to be able to vary these input conditions, right? I want to be able to change this ping between rounds without having to fucking come here and manually change it, you know, and then run around, change it, run another round, and then change it, and then do that again, you know, because the problem is, let's suppose we want to run 5 levels of ping, right? And then let's suppose that that we want to run different levels of, let's just say our here we have an honest scoring, right? Let's suppose that we want to change this K and this L, right? We want to run 3 levels of K and another 3 levels of L. So that's 3 times 3 times 5, right? That's already 100 different rounds that would be run just for that. That's not even to consider changing, right, the K thresh and the retort policy, or the various selfish, stubborn mining things that you can do, right? So you're looking at thousands of different rounds and combinations, and this is how you have to search a problem space to find your minimum optimal. Usually you're trying to minimize something, right? Like minimize the reorg length and minimize the selfish profit. So you have to sweep over literally thousands of combinations of so many different things that you can do, you know. And you'll notice here, right, there's a depth penalty based on time. We could do a depth penalty based on the number of blocks of reorg. We could give an uncle bonus based on time, or an uncle bonus based on the number of blocks. We can also say, what does the timestamp skew look like? And again, we have to check all of these different things in relation to the different strategies that the selfish miners could deploy, and we have to do that under various network conditions, right, of various pings. So you can understand, hopefully you're starting to understand the scope of the problem space isn't just as simple as like, hey, I have an idea, let me run a quick simulation and see if it works or not. No. That's great. Like, you have an idea, let's simulate it, but we have to simulate it. Every idea has different tuning parameters, and it has to be able to perform against under various network conditions where we might have degraded global internet. It needs to be able to perform relative to other strategies, right? It needs to show that it's better than other possible strategies, and it needs to show that it can actually partition heal. Like, if the network ever becomes fractured, say a global internet outage, the network needs to be able to heal, and we have to be able to check all of that. So you can see this is like very, very close to being able to do sweeps. I'm not quite there yet. I did all of the setup the past couple days. I made poor coding decisions early on that I had to pay for. My sins had to be paid for in the past couple days to set up the code in such a way that I can implement the sweeps that we're talking about, right? So that we can actually programmatically vary all of these different parameters without having to hand jam the config every single time that you want to change something, right? Instead, you can have a single file that says, okay, change this, this, and this at these levels. It'll automatically generate all the possible combinations and then sweep through them at however many hours that you say to do. So the last little bragging point that we can do to set this off while Tux comes back is I'm going to set this for a full year of calculation. We're only going to run one round. We're going to set this
I am here. Were you waiting for me for something?
No. I was just I don't know. Just saying that we'll, I'm going to set this off to run for a second. It's going to take about 40 seconds. The last thing I'll show before we just chit chat again is let's see, package.json. So these are all like the easy way to run this. So you'll notice we've been doing npm start, right? So you can come in here and sort of make your own little simple scripts. But what we're going to do is run data mode simple right here, because we actually, like, despite the fact that that you can go in here. One thing I forgot to show you guys is the scores. So I call them scores 001. We're just going to look at that one. This is what all of the pools see individually, right? So you can see that there's an index and then there's a pool ID. And then the block ID is just the height and then underscore the pool that mined it. So you can see that we sweep through all of the pools, right. So there's a lot of data in here. It's 35,000 lines. Anyways, I just wanted to show you guys that. I'm sure you always figure that out on your own. But the point is that you don't actually need all of the blocks and you don't actually need all of the scores. And that actually slows the simulation down because you have to gzip all of that. So instead, what we're going to do is run a simple version of this where you can just do npm run sim simple, right? So that's going to not produce the blocks or scores. It's just going to produce the results summary. And this will take about 40 seconds to run, but we're going to run an entire year's worth of simulation here. So yeah, that'll take a second. I don't know if Tux, you want to come back online and give your commentary.
All right, this is a pretty cool simulation that you created. I like how you laid it out. How you're able to choose the different, I guess, mining style for each pool, and it's very clear with the different modes that you've set up. How long did it take you to set all this up? I'm guessing you worked over this over the course of several weeks at least, right?
Yeah, I started this about 5 weeks ago.
Okay.
Maybe it was 6 weeks ago. Yeah, so yeah, maybe not the fastest absolute turnaround time, but it's correct. Like, that's the thing. I can't I can't guarantee that it's correct, but I mean, it's written in a way that you can read the code and understand it. It's not like an arcane method of writing code. It's a functional style. It's not object oriented. I hate object orientation, but that's a different conversation. But you should be able to read the code if you're interested in it. I tried to name everything in ways that like made a lot of sense. And again, it's like, it's correct. It's modular. It's pluggable. Arctic has been talking about changing, there has been some talk about changing the difficulty algorithm and like changing the block time, stuff like that. So I am thinking about trying to pluggable modularize the difficulty adjustment algorithm. Right now it's sort of integrated into the sim core, but I could pull that out just as easy. And everything in here, like I said, it's all fairly well modularized. All the things that you want to do have their own little functions. And then you can easily pull that out if you wanted to. So anyways, yeah, that took about 40 seconds to run. And you can see that, again, we can go in here and look at our results summary, right? We ran a year's worth of simulation. And these are the results that we're getting. So anyways, yeah, if people if you have ideas and you know a little bit of JavaScript, it should be, with the help of an LLM, you should be able to make sense of this and write your own countermeasures and test them and everything. So.
That is very awesome. And I mean, yeah, that's kind of what Node is good for. Like, it's like maybe it's overused for software in general, but this is like a great use of it. And it allowed you to easily set this up and within a reasonable amount of time, create this program that's modular. And of course, the environment is very easy to understand what's going on. And from there, I'm sure if you want to be more experienced, you could look at the code and, maybe make your own modules as well. But very cool.
Yeah, I'd be 100% open if anyone wants to like hop on this project and say, hey, you know what, let's add in some modules for transactions and dynamic blocks. I bet you Arctic would be pretty happy if someone wanted to do that. I would like to say that I could do that, but I honestly, there's no chance I can say I can get to that with all the work in front of me that, you know, still needs to be done for the selfish mining stuff. But if someone wants to get in here and start beefing up the simulation, and or like I have a whole stochastic model that makes certain assumptions, but if you wanted to get in there and check the literature and find out what is a more realistic representation of ping and all that kind of stuff, I would be totally open to anyone that wants to contribute. So it's at the level that I can sort of open it up and say, hey, if you want to contribute, jump on in. You know, because now I'm confident that the architecture is correct.
And has the MRL used this at any capacity to help get insight?
No, not yet. They're all, for the most part, working on their individual modules.
Yeah, that makes sense.
Yeah, what they're waiting for is for me to like say, okay, here's my model. Here's the results that I'm getting from it. They have, you know, listened. So last week on the MRL meeting, I said, hey, you know, here's what I'm seeing with my SEM as far as reorgs go, right? Here's what hypothetically they could do with a certain amount of hash power and certain strategies. And Rucknium, you know, he was a little bit interested in that. But they're waiting for me to produce something, right? Because they're all hella busy, you know, and they're trying to get the DNS checkpoints rolled out. So they don't really have time to go in here and play with my model.
And I guess that became kind of, once again, I've not been keeping up very much with it, especially over the past few weeks. But it looked like the DNS checkpoints became the main priority over the past month. At some point, it was decided that was going to be used as a temporary stopgap in significantly reducing their ability to selfish mine as effectively.
Yeah, exactly. It was when we had the first 20 or 18 block reorg. That was, they call it the Grim trigger. that's what they call it.
Yep.
So that happened a few times now. So it's not as like back in 2014. It was a lot easier to pull the trigger on a DNS checkpoint to stop the ASICs. But it's a lot harder now because, you know, we're not a budding, aspiring new network. We are a multi-billion-dollar network. So